Thank you everyone for being here. I'm Venkateshu. I head analytics practice, which is part of data analytics unit of Infosys, and I'm based out of Bangalore office of Infosys. I'm responsible for analytics and AI work for clients across industry segments and geographies. I've been with Infosys for the past 27 years. Last 4 to 5 years, there has been an increase in adoption of analytics and AI by the enterprises. Hence, there is an increase in demand for skills people in analytics. At the same time, we also see that many universities, institutes are stepping up by offering full-time, part-time, online programs in analytics and data science and AI, etc. Now, there has been a gap between theory and practice while adoption of analytics and AI to solve problems for enterprises. And one more challenge with the current pandemic is that globally organizations are trying to recalibrate themselves to new normal and adjusting to this pandemic and unearthing new responses to tackle business problems that are at hand. Today, we have brought together some of our leaders from analytics practice, and they are also practitioners for an exclusive panel discussion. We, along with these four distinguished leaders from analytics practice, will discuss these challenges. Now, I would request the panelists to introduce themselves. Princey, request you to start with you.
Thanks, Seshu. I'm part of Seshu's team and I lead social media and web analytics across industry segments. Happily working in Infosys for the last 14 plus years. I specialize in topics like social media based research and analysis, social media marketing, text and sentiment analysis. Me and my team, we help some of the top brands understand their consumers better. And our team of web analysts are helping companies optimize the performance and consumer experience on their websites. Thank you. Over to you, Seshu.
Dr. Anthony, over to you.
Hi, hello everyone. Good evening. I'm Anthony. I'll head the operations research group within Infosys Data Analytics Group. I have close to 18 years of experience in solving business problems in supply chain. My areas of expertise are supply chain, machine learning, and discrete event simulation. My team primarily focus on research and innovation to solve complex problems such as network optimization, routing, scheduling, predictive maintenance, inventory management, and forecasting. I have published research papers in international journals and conferences. I have granted patents in US PTO. I also act as a reviewer and guest editors to some of the international journals and conferences, and occasionally deliver talks in engineering schools and management schools across India. Looking for a good interaction today. Thank you.
Over to you, Dr. Puranjay.
Hi, I'm Puranjay. I work in the areas of advanced analytics and AI, and I consult across verticals. I also drive the computer vision activity in my unit at Infosys. I come from a background in digital signal processing, pattern recognition, and machine learning. I have published two recent articles, one called The Elusive Goal of Automated Deep Modeling, which was at LinkedIn, and the other one called Explainable AI, A Practical Perspective, which was on the Infosys website, and I did a parallel posting of that on LinkedIn as well. Over to you, Seshu.
Over to you, Subhashish. Subhashish. Subhashish, can you please introduce yourself? Okay, I think we lost one of our panelists. What I would request with some questions, Princey, you said that you are working in social analytics, web analytics, and brands are leveraging this. Can you talk a little bit more details about what kind of work that you do and how these brands are benefiting from the work that you do?
Sure, Seshu. So, as we all know, last few years has seen a lot of rapid increase in social media usage. In in 2015, there were about 2 billion active users on social media, and today it's about 3.8 billion people. Almost half of the world population is using social media, and they're spending on an average 2.5 hours per day. Uh, while they are at social media, consumers are giving every kind of input or feedback on how their day went about, what they ate, what sports they prefer to play, types of shoes they want to wear, or clothing that are getting popular, their color preferences. I mean, only and we've been helping companies and brands just understand the color preferences of consumers and helping the company, the brands increase their sales just by giving an input on, uh, don't use this color, but maybe another color, which has led to direct impact on sales. Um, so we help the brands understand what is the perception of the consumer about their brands, what are the changing lifestyles of the consumers, including a lot of, so for CPG companies or food brands, what are the changing food related preferences or changing lifestyle? It's going towards more healthier options or vegan options or even more sustainable options, wherein people are asking for more and more plastic, less packaging. All of these inputs are going with the brands, and they have now data driven approach to taking decisions much better than before. Of course, there's a lot of noise, and finding those useful patterns for the brands and companies is a challenge. And we are exactly doing that, helping brands understand the consumer behavior in a noiseless way, and identifying those patterns to change, for brands to change their products to suit consumer needs better. There's also another positive point about social media, in the sense that not just about your own brand, you're also able to check what consumers perceptions are towards your competitor brands, and that also comes as a great feedback for brands to know and and see what are the innovations that are happening at the competitor side, which consumers are liking, which they could also bring in. And we've been able to help brands introduce one such option on vegan kind of a trend coming up, and suggesting the brand to adopt it. So there are also other ways of finding out through social media what are the industry specific issues that are emerging that companies need to be aware of so that they can plan ahead. um, so these are various ways on which social media, and what we do is we are able to help brands, including of course increasing through social media marketing the reach of the brand, and how to positively engage the consumers through social media marketing. Thank you, Seshu. Over to you.
Thank you, Princey. Dr. Anthony, you said that you work in supply chain, logistics, and other areas related to optimization. Can you talk about the kind of work that you do and what kind of challenges that you face while solving the problems?
Yeah. Yeah, Shishu. Yeah. We did some interesting work for top logistics companies based out across the globe, in which we have automated their business process using optimization, AI, and machine learning. We have solved complex optimization problems such as facility location problems, routing problems, and price optimization. I'll talk about one such engagement which we did very recently. Right, most of the logistic service providers involved in broking business. Right, what they try to do is they want to predict the carrier cost. Let me elaborate a little bit more in detail. Right, so the broker acts as a bridge between supplier and the carriers. Right, the shipper companies like shippers are like Walmart, Lowe's, and so on. They want to move their consignment from one location to another in within their supply chain. The interesting part here is the shipper wants to find a better carrier or a better broker who will provide that service for a cheaper rate, wherein the broker wants to maximize his income, right, from the shipper. So the bidding this process starts with the bidding, wherein the shipper provides the information like the origin, destination, date and time of pickup, and requests the bid from different logistic service providers. Once the process starts in, right, the bidder with the who plus the lowest bid will win the win. So if the logistics provider came up with a higher price, he may lose the bid there itself. So he will lose the business. So it is very it's very uh, difficult to find out what is the right price I should bid the load so that I can win the load. And in the other side, once the logistics service provider wins the load, he now goes to the market to find a carrier to move the load. Now the challenge comes in the carrier in most of the logistics market is very dynamic. So the carrier rate is not same as what you see today will not be there tomorrow. So it changes dynamically based on the capacity, demand, and the market movements. So now once the load is won by the logistics provider, he goes to the carrier and asks carrier companies who want truck to bid for that particular load. Now the carriers will bid, and now the logistics service provider wants to lower the cost, right? That is going to incur that he's going to pay to the carriers. So now the challenge here is to come up with the right price, which will help them to win the bid, as well as to secure the carrier. So this is a very interesting problem. We have created a solution for predicting the price for these carriers, for the brokers, wherein it will help both in the carrier side of the thing as well as from the shipper side of the business. This particular solution was built in Microsoft Azure, Databricks, and the challenges that we faced are mostly in real life scenario. You'll find that a lot of data will not be available. Sometimes you need to rely on the third party service data sources, which comes with a lot of contractual classes as well. And you may not find the forecast because we are going to predict for the future. We need to get the forecast for the market indices. So there are a lot of challenges like that, and the other important challenges will be the computational time that is required to run the models, as well as to serve the results to the end user within few seconds or few milliseconds. So these are the other side of the challenges that we face in solving real life business use cases. Over to you, Sheshu.
Thank you, Dr. Anthony. Now we have the other panelist, Subhashish is back. I would request Subhashish to introduce himself.
Yeah, hi. I'm Subhashish. I lead the verticals of consumer goods, retail, and logistics within analytics practice. For a decade and a half in my early career, I was a business consultant, and those were the days before analytics used to be an established practice. And we used to do business problem solving using math, which is analytics, and we used to do the use cases like forecasting and pricing and clustering and all of that as part of business consulting. And now, even though analytics has come of age with the open source revolution, the computing intensities that are possible today, but we still bring that same mindset. It's a business problem solving mindset, though using analytics. So glad to be here. Back to you, Sesh.
Thank you, Subhashish. Dr. Puranja, you were introducing and you talked about computer vision and advanced AI work that you do. Can you please talk about some of the interesting things that you're doing in AI?
When it comes to implementing practical solutions, let us say, for example, if you want to find out the complete customer behavior in one of the stores from the point where the customer enters the store to the point where the customer leaves the store and handles a lot of objects in between, it takes for us a lot more than the basic building block that you commonly study in universities, which is how to take a big data set and train one of the neural network models using either something like Keras or PyTorch. Here, one of the first problems we face is dearth of data. We go to the extent of using 3D models, which are artificially generated, to generate a data set on which we do the training for different objects. When it comes to the models, the specialization that we have to build in is how to recognize a very large number of models, say close to 100 or more, which are very similar looking in nature, because these kind of problems frequently occur in real life. Then there's a question of integrating multiple camera views. Let us say you have something like 15 cameras in a store. So many of them are looking at the very same kind of things. And the question is, how do you integrate them into one single view? Uh, Fourth point would be, how do you maintain throughput so that you can process something like all these 15 different camera streams using a single GPU? Last but not least, the point that we always have to keep in mind when we are dealing with advanced analytics and AI is that in the end, the model performance of the raw model that does computer vision is not the same as the performance that is required by the customer. The customer just needs a job to be done, and that is finally the end goal. So in our case, it is very important to be able to have models that work imperfectly, something like 70 to 80% kind of accuracy levels, and yet meet the final customer constraints. So these are some of the things that need to be bridged when one is taking the base computer vision theory into a practical computer vision solution. Over to you, Seshu.
Thank you. Subhashish, you said that you have been building models for forecasting and various business problems. What's new that you are doing now? With a lot of cloud and various things that are happening. What's new things that you're doing now?
Yeah. So in terms of there are some things that remain the same, which is of course getting the fundamentals right, converting a business problem into an analytical construct, and then creating the models for that. The things that have changed in the past, when you're building a forecasting model, I remember we knew the complexities that could be added to get more accuracy and so on, but just for the performance windows we would not do that because in the old days, a complex algorithm could run all night, and we had these batch processing times that you had to be aware of. But nowadays, with the compute intensity having increased, there are forecasting engagements that we are doing where we have ensembles of models, we have multiple models running, we have automated code selecting the right model based on the accuracy derived so far, and so you have you're going away from the dependency on the data scientist to always sit and choose models and so on. So that is basically something that the advent of open source and compute intensity allows you to do. With cloud, of course, the experimentation angle has increased. So you are able to experiment much more today because you have these the cloud costs are elastic costs, which means you do not have a very large fixed investment if you want to try out something. So the experimentation on analytics has increased significantly. So you see most organizations following a process of doing proofs of concepts, prototypes, and then productionizing. And it is in this productionizing area that we are helping a lot of clients again because of obviously the Infosys technology background and the analytics skills that we bring. When we merge those, we are able to bring a lot of industrialization in how analytics is applied. Just to take a couple of examples, traditionally you may use say statistical algorithms or GLM models for media mix modeling. However, when you are basically applying it to production, you may decide that an AI model makes better sense, even though there are obviously you need to keep monitoring that model as well. Nothing is maintenance free, but you can use AI models to reduce the dependency on human modeling, data transformations, etc., all the time. In addition, there is the angle of optimization that we do a lot today, because when you are automating a process, the scale of that analytics may be such that if you had a human bottleneck, if a human being had to make decisions based on the analytical outputs, that may be too much of a stress on that human being in terms of scale. And so we bring in optimization where not only the analytical output is created, but it is compared and the most optimal decision is taken, and all of that is automated. So a lot of those things, I wouldn't say completely new. Optimization used to happen earlier as well, but the scale at which it is being adopted is definitely due to the computing power and cloud resources that are becoming available. Back to you, Saish.
Thank you, Subhashish. Pulunjay, there is an interesting question from one of the participants. The question is related to the explainability ethics on the AI. I think the question is follows: AI picks up the biases and stereotypes it observes in the data and makes recommendations based on that. That's a question. So, I think probably question is how do you prevent that? I think what do you do for this?
Um, Hi, Seshu. Uh, yeah, this happens to be one of the big problems, because when we are looking at machine learning in general and deep learning in particular, whatever we include as part of the data sets is what decides what the models will finally deliver. So if there is a lot of if there are a lot of biases in the data, some of the first biases pointed out was with regard to various racial profiles, etc., in the face data that is available today. And it kind of goes on. So it has become very important for us to first of all become aware of these biases, and thereafter to remove these biases from the data set, so that the models that are trained are unbiased. You might have heard about AI 360 kind of terms, and different toolkits have come out. Mainly what these do is, on one hand, they do a statistical modeling that first of all detects all the biases, and then through techniques such as resampling or calibration, those are readjusted so that we can end up with relatively unbiased data that can thereafter be used for model training.
Thank you, Dr. Purnanjay. Subhashi, there's an interesting question here for you. I think this is related to the data. For an organization to implement AI initiative, they must have access to the trustable, relevant, and constant source of data. How can organizations navigate this cold start problem?
So that's a good question. You need to have access to relevant and constant source of data. Now, there are multiple ways an organization can navigate a cold start problem. It is about, there is a role called data hunters that is becoming prevalent in organizations today. And what these data hunters do is, first of all, when you create a hypothesis of how a certain business problem will be solved using analytics or AI, what is the data requirement? Now, this data requirement is then analyzed and sorted in terms of what is available internally and what needs to be sourced externally. And there are situations like data surrogates. There is this example of when clustering stores, for example, in retail. If you are interested in what are the demographics that shop near that store, there are multiple options, right? One is you could buy market data about the demographics around certain locations. You could also look at, nowadays there are tie-ups with mobile phone industries who basically provide subscriber data. And if you have a couple of large service providers, that is as good as almost census data. That is also the case of how you can use data surrogates in terms of the product types in being sold in that store. So, if it's a basket that has kids products, shaving products, there is a male in the household, there is a kid in the household. If it's mostly convenience items that are bought, then this is what is called a singles basket, and so on. So you can use the surrogate of product type to identify demographics that shop in that store. And then that is something, once you have created those changes in product masters, you have identified certain products as what kind of segments are likely to buy them. You can then use that as a constant source of data in terms of what demographics are shopping that store to feed your models. So in terms of the data availability issues, you basically have to start. It has to be a roadmap. You basically build your models based on the data available, but you make a plan to collect more and more data that will help you get to the ideal or more complex models. And that is how you make a roadmap, so that you can start, but you don't start sprinting. You crawl, walk, and run. Yeah.
Thank you, Subhashish. There's an interesting question for Princey. Social analytics, how is it being used to influence purchase habits? Princey, over to you.
So it ties back to actually one of our couple of projects we are doing in terms of influencer analytics and key opinion leader analytics, wherein brands increasingly are using micro influencers, macro influencers, or even, of course, celebrities have been traditionally used to attract or inspire the followers who are a very niche target market or for the brand through these influencers by posting through fitness experts or back to school mothers to if that is the purpose of the brand. So yes, influencer marketing is what brands are using, and we are helping do that, helping brands do KOL analytics or key opinion leader analytics by selecting the right KOLs or influencers, specific not just to a demography or geography, but to the very specific interests that target market has, and now also how people are perceiving those influencers, whether positively or negatively, irrespective of the follower size or engagement that they get. Thank you. Over to you, Seshu.
Thank you. Dr. Puranjay, there's an interesting problem of overtraining the models to get better accurate results. Should we do that or not do that?
When it comes to a model, uh, there is a question of either overfitting or underfitting during the training process. Now, these two things arise from the fact that the model has a certain capacity, and every model, depending on the number of parameters, you could take the rule of thumb to be that typically we need 10 times as much data as the number of parameters. So as the number of parameters goes up, you need more data to train. By overtraining, what I think you mean is when one is going ahead and doing overfitting, that is not going to give you a good model, because what happens is that it's going to give you much better results on the training set, but when it comes to either the validation set or the test set or the final deployed model, it's not going to work well at all, because it has not generalized well enough. Rather, it has very closely figured out how to model the characteristics of the data at hand. So in summary, when fitting the model, we should neither overfit nor underfit. We have to achieve something in between.
Thank you, Dr. Puranjay. Dr. Anthony, there's a question about is master's degree important to be a data science or analytics professional?
That's a good question, I would say. Yeah, to have a successful career in data and analytics, I think a data scientist should have knowledge in statistics and probability, and then something around computer science engineering, and then the domain, right? I would focus on the first two mostly, because that's what we'll acquire in a master's degree. So if a person is lacking in one particular skill, right? For example, he is having a bachelor's degree in computer science and he doesn't know much about data and analytics or about AI and machine learning, then I would suggest recommend them to take a course in take a course in masters in data analytics. Whereas if a person is already having that particular uh, uh, skill, he's coming from a computer science background, he lacks in statistics and probability, then I would suggest to go for it, right? But it's not mandated to have a master's degree to have a successful career in data analytics. But if they need to augment their skill and upskill themselves, then certainly it will help them. The other thing they can do is participate in some of these competitions like Kaggle and the other organizations which post as challenges in the data science area, and try to learn from that. That will really help, right? Most of the, I would suggest go for a on the job training uh, rather than going for a formal master's degree. But at the same time, if somebody is lacking in some of these knowledges, it will be better to go for it and augment their skill. Over to you, Shesh.
Thank you. Princy, there's a question for you. How much of accuracy can be attained with analytics in social media?
Yeah. So before I answer that question, I wanted to point out what are the kind of inaccuracies we kind of see in social data, both quantitatively and qualitatively. From a quantitative standpoint, whoever has used some of the off-the-shelf available tools, which kind of tell what is the share of voice of various social media platforms where the conversations are happening. Typically, one would see Twitter as number one in terms of the number of conversations. However, that is not so true if one looks deeper into it. And I think knowledge of the how the platform works, the social platform like Facebook, Twitter work, and how which kind of numbers are exaggerated, like retweets, is a way of sharing on Twitter, while on Facebook, the share is not a mention but just a kind of an engagement. I think understanding of that only, we've been able to actually help one of the top sporting goods companies, who have been reporting on this metric for a very long time. We've been able to help them understand this and correct it for future and reduce those inaccuracies on quantitative terms. How to interpret reach, engagement at that level, and then qualitatively. More and more, which qualitative is more about text analytics, usage of NLP, and using machine learning algorithms for text classification. The more data we train, and of course there has to be a human eye to, as well as an eye, a domain specialist for that particular industry segment who understands that industry, to be able to classify that text first, the create a training set, and then on top of which the analysis or the can be done. We are using newer techniques like BERT, as well as Facebook specific techniques, Infosys. For image analytics, we are dependent on classified models that are provided by Instagram, because it's so image rich that it is a very strong repository of providing a training data set, that it becomes very useful. So considering all these factors, we've been able to increase our accuracy over a period of time, from 75 to 80% for text classification as well as image analytics for social analytics. Thank you. Over to you, Seshu.
Thank you, Princy. There's so much behind the social analytics. There's an interesting question, Dr. Puranjay. Question is, there are so many algorithms, Gaussian, neural networks, etc. How do one select the right one for a particular business problem?
Hi, Seshu. Regarding this particular question, this relates to a great extent on the kind of data that we have available for the particular problem. What happens is this: today, building models has become very easy, and fitting them using either the toolkits, toolboxes available, let us say scikit-learn, or we are looking at TensorFlow-based neural networks. It has become extremely easy to fit these models. But the first question that we should be asking is, how much data do we have? If we have a small amount of data, then neural networks will not be a good fit. What is the quality of the data? That is very, very important, because if the data is noisy, quite often it might end up that the neural network might adequately model some of the noise elements inside, and not be able to actually bring out what is required of the model. Then the question that comes is one of um, how much additional kind of data or models do we have in the area. So in case of neural networks, this is a question related to whether you can do transfer learning or something. Then the question of how interpretable do we need the models to be? If we want something close to total transparency, then it is important for us to have models which are relatively simple but interpretable. It could even be something like logistic regression. I think you would be aware that when it comes to the financial area, people commonly do not like to use neural networks because they do not have that degree of transparency and predictability of all these models. So all of these are different aspects that go into deciding which particular model to choose. There is no one single good answer. It depends upon the data at hand.
Thank you, Dr. Puranjay. Dr. Anthony, do you want to add anything to this as a practitioner?
Yeah, I would like to add few points, Eshu. Dr. Puranjay touched most of the points, but I would like to add, right, when it comes to business problem, we need to understand whether we need to go for very complex models like neural network or not. That should be the first question. If you can solve the problem using a simple model, go for it. There is nothing fancy needed to solve a problem. Ultimately, you need to solve the business problem. That's very important. The second thing is, the other aspect that I would like to talk about is the computational time available to run a model. Say, for example, if you want to predict whether a person is going to commit a fraud or not in an online business, then if you can, whichever model that can give you a quick result, that's what you should aim for. Though the model training can happen offline and you can still store it, but whichever model will be fast enough to give that kind of response, you should go for those kind of models. The third one I would like to add is uh, whether it can explain, like what Dr. Puranjay was mentioning, right? Whether I can explain why I've taken this, why the model has given this particular output. That is also very critical when you talk about using these models in business, in solving business problems. So you should keep all those things in mind while we select a model. Over to you, Shashi.
Thank you. Very practical approach to solving problems. Subhashis, there's a question about how AI analytics is used in manufacturing industry. Any examples that you want to give, Subhashish?
Yeah, sure. So, any industry. So now analytics is so pervasive. If you were to draw a value chain of an industry from left to right, if you take the manufacturing industry, if it is about sourcing raw material, inventory management of raw material, the line allocation of where the production will happen, the actual adjustment of the line, the fine tuning of the line as it happens, and then the raw finished goods inventory management, distribution of the same, all of that, right? The entire process can use analytics, because, as I said, analytics is about smartening a process. So, if I were to take examples, in manufacturing, if you look at raw material coming in, maintaining the inventory of the raw material requires the collaboration with the manufacturing resource plan, the MRPs, and being able to plan for supply chain risk or uncertainty. So we have certain models like supply chain early warning models. So those industries who get raw materials from longer supply chains, or longer lead time supply chains, I find a lot of use in the supply chain early warning, because it uses news blog data and Twitter data and predicts supply chain shortages, and so that you can plan either alternate supplies, or you can plan your manufacturing accordingly. So that's in the raw material area. Line allocation, this is very interesting, that today, which lines will be used to produce how much of the required quantity is something that if you do a good selection, you will have good capacity utilization, you will have good yield across based on the lines that you have. So to make the best decisions of that, again, analytics is being used because you know how much you are required to produce, you know how much it's going to cost, you know the yields of various lines, and you know the minimum utilization that you want to aim for. So that that is something where analytics is being used in a big way. In within manufacturing itself, there are situations where we have used IoT data to fine tune the process so as to reduce or increase moisture in cheese, for example. So for one of our clients, the moisture content in cheese was extremely important because if you have less than the required moisture, then the quality is not good. If you have more than the required moisture, then you basically are selling water at the cost of cheese, and again, that is basically not the right sort of texture in the cheese. And to keep moisture within a certain range, there are devices which are letting us know the ambient humidity and temperature and so on, and certain steps of the process are being controlled so that the finally the moisture content in that food item is optimal. So there were studies in this area that were done for one of our clients. So there are multiple areas. I'm not touching upon consciously the predictive maintenance, which is the lion's share of analytics, I guess, whenever someone thinks of manufacturing. But those are also, of course, there. You can predict whether a machine has to be taken off for preventive maintenance and so on, reducing downtimes of the machines. And so AI and analytics, it's everywhere. I would say everywhere in manufacturing you can use AI and analytics, and there are so many more examples.
Thank you, Subhash. It's very interesting. I have a question, two related questions to Dr. Puranjay. One is about reinforcement learning. How do you use this? And second is how do you handle the insufficient data while building the models?
I missed the second part of the question.
Insufficient data. Yeah,
To you.
insufficient data. How do you handle when you have
Okay.
insufficient data?
So let me first talk briefly about the reinforcement learning part. Reinforcement learning is a fairly old technique in AI, which right now with neural networks has some new avatars like deep Q learning and so on, and they are extremely powerful. The main problem is that with reinforcement learning, um, uh, to begin with, one needs, if one is looking at deep reinforcement learning, then a lot of data is necessary, about 10 times more data than uh, what is required to build a typical neural network model. Also, what happens is that we require a lot of negative examples. Like I think there was this remark that if you want self-autonomous cars to learn using reinforcement learning, then you need them to be able to roll down cliffs quite a number of times, and you need to have data for that. Uh, in the absence of that, what happens is that reinforcement learning becomes very easy when it comes to making game engines that can be kind of played against one another. But in real life, reinforcement learning until now has not become very mainstream in deployment. um, when we take a particular problem, the first issue becomes how do we model the different kind of interactions of the environment with the agent. What are the things that can be regarded as reinforcements or kind of penalties or um, kind of gains that can be provided to the agent based on a particular state or a particular action and so on. So overall, it is not a very direct fit. Sometimes reinforcement learning can be um, uh, very nicely molded into a problem, particularly where you don't have the situation where you immediately don't have an output, but rather the output comes after a long time. But it is not directly one of the, or it is not currently one of the direct approaches that one would use in trying to build a model. Let me try to go to the other question, that of insufficient data, and let me look at the context of computer vision. Insufficient data is very, very common when it comes to the question of building models in actual customer projects. Customer hardly ever has any labeled data. So the first thing that people would talk about is, well, supposing you do have a little bit of labeled data, why don't you go in for data augmentation? Data augmentation comprises techniques where you kind of modify the data, in the case of computer vision using image processing, to generate a lot more data. Then something that we are currently using is synthetic data generation. So we first take some pictures, use those pictures to generate some 3D models, and then use those 3D models to generate data. Um, in a larger perspective, however, one of the simplest ways for us to manage with less amount of data is to use, especially this is for neural networks, is to use transfer learning. So this is very, very applicable, where you can, to begin with, find a neural network model of something that is similar. So very often what we do is we start off with a stock model which is trained on ImageNet dataset or some other dataset, and then we start doing transfer learning on that. But even that transfer learning today needs a lot of data. If you look at YOLO 3, for example, the first 52 layers are derived from older models trained using ImageNet. The top models, the top layers are all trained, another 52 layers or so. They are trained using additional data. Now, more and more, we are getting into areas of semi-supervised learning, where only part of the data set is labeled, and it's kind of a place where we are using a mixture of supervised and unsupervised learning a lot of time. One specific type of semi-supervised learning which has become very important for us is called active learning, and we have already deployed it in some projects. In active learning, what happens is you start bootstrapping the model. You first train a very basic model based on a very little amount of labeled data. Then using that, you identify other data points which, if labeled, will give you the maximum bang for the buck. And then you use these to retrain the model, and you put the whole thing through several cycles, so that the model, the bootstrapped model, slowly keeps on building up performance until you reach the level of performance where you're satisfied. So these are the set of techniques that one commonly uses when you have very little amount of data.
Thank you, Dr. Puranja. Very interesting. Princey, the next question is for you. How do we remove the noise from the data? And also, there's some questions about deep fake and all these things, and also images, videos. How do they avoid, and how to effectively train better and then get a more better model accuracy?
Right. So I'll address the first question. How do we remove the noise? And we have seen, and I think anybody who has worked on Twitter API directly, getting the free 1,000 comments, I think mostly students try that, and they would see that some word cloud forming and certain words appearing very bright, but not very meaningful. And over a period of time with experience, what we've seen is that if a company is posting a tweet, it's a marketing campaign tweet, and people are retweeting, that is also being considered as a mention. And what that does is basically the same message of the marketing campaign is getting seen in that word cloud a lot. And that noun clouds or word clouds or bigrams, n-grams, they are very popular in most listening tools as well. And at the face of it, it will not give the insight though the user is looking for. What we have helped for many of our brands, what we do is first of all decide the platform that you are considering. You might want to negate all the retweets of the owned posts to get a better sense of what are the replies that people are actually posting an opinionated comment about for that particular post that the or the campaign that the brand has written about. So there are two things here. One is giving an additional attribute to what is the context, and that we can put a filter when we have our own visualization. You can bring a context by tagging or labeling the post on top of which the reply is, uh, so that in the workload that you get, you are not getting the brand's comments but the only the consumer comments, and in that sense you have already simplified the word cloud to reflect only consumer specific comments, and that also very specific to a particular post that a brand is posting. It could be about a product, so you already have awareness of which product it is about. Second kind of noise that we see is if you are researching a trend of not specific to a product or a brand or a company, but in general you are searching about a trend of about chocolates, about anything. Um, there is again a lot of noise in terms of people putting all kinds of comments. But what we want to really look at is opinionated conversation comments. What we've seen for some of our brands is that there was no insight, and because 80% of the conversations either were one word or were not positive sentiment, half 80% were neutral. When we remove 80% of this neutral, you make the data set that 20% of positive and negative conversations, which actually forms your 100% of universe for opinionated conversations, because those are the conversations from which where people are talking about an opinion becomes your universe, and then you try to find out what is the intent to purchase, if that is objective, amongst those 20% conversations. Now, if your intent to purchase is about 30%, right, of that 20%, 30% is still a metric that if you tell a marketer is strong enough, while 30% of 20% in the overall, which is just about 6%, people at the marketing level or brand marketing level, they will just say that it's too small a number to make any difference. However, we've seen, out of all the conversations, if it's about 6%, they are very, very useful comments, because we just need to find, the analyst needs to find the right way of depicting that information in the visualization to ensure that the stakeholders and the senior management understand why the small percentage is important. So these are some of the ways, and of course there are many other kinds of noises that are there. In image analytics, we had a very interesting problem from one of our fast fashion retailers, wherein they had a specific problem of how if people are tagging a specific trend about jumpsuits, for example, the Instagram picture would not carry it, and they wanted to see how the hashtag jumpsuits was trending over a period of time. So of course through image analytics, and if we are only going by the hashtagging, we might not get the right trend. So using we were able
Hello.
to generate some of the fakes.
I think we're not able to hear Princey. I would like to ask Dr. Anthony the next question. This is about how do non-tech, non-analytics companies can survive in this AI era. Yeah, Anthony, want to add anything to this?
Yeah. So most of our clients, right, they are mostly non-tech and non-analytics company. Means they are there for a long time. They are serving their industry long time, but they are not very tech savvy or analytics enabled companies. Even in my college days, I used to expect that all the companies, the top companies, used to have all the facilities. But to my surprise, when I came to industry, I saw they're lagging either in technology or in analytics. So I think that myth should be cleared now that not all the companies are analytics enabled, and technically also they are not very superior. But some of them are. Right? I'm not saying everyone, but some of them are. So, jokes apart, so that's why we are there. We can go and embed ourselves into the client team and set up their data science practice within their company, and then slowly transition that to the client team, right? So we are there to help the clients in that kind of scenario where we can go and embed ourselves, understand the business process, understand what is their requirement, and come up with an organization structure for what is needed for that particular company, and then transition it to the parent organizations. Over to you, Shesh.
Thank you. Subhashish, there's an interesting question for you in this. What are AI developments in production, supply chain, logistics, finance? Anything that you want to talk about that? Maybe after that, Anthony can also add.
Yeah, so sure. So production, I think we already touched upon, which was the manufacturing question. Right, in supply chain, see, the entire role of supply chain is basically to ensure the movement and storage of goods to provide for the demand. The demand could be a business demand in terms of they needing some raw material for production, or the demand could be consumption demand, as in a consumer coming to buy something. So the entire task of supply chain is obviously there, and traditionally you had this concept of supply chain planning and supply chain execution. So what used to happen is, the supply chain plans will lay out that these are the places where my warehouses are, these are my transporters, and this is basically how my supply chain is expected to run. This is the orders that I'm expected to make, and so on. And execution was expected to vary from the plan, because not everything will go according to plan. There will be shortages of orders, there'll be trucks not arriving on time, and so on. And execution was supposed to be basically managing based on that. Now, so in one sense, the entire operation of supply chain can be brought down into supply chain risk management, if you define risk as anything that is not going according to plan, and also, of course, the initial supply chain planning. What is happening now is you are able to sort of merge planning and execution, in the sense that it is no longer required to make a very long term plan, except for where you are doing capital investments and so on. Except for those, in terms of the quantity of products to order and move, etc., you don't need very long term plans. You make plans strictly based on the lead times that are there from your sources to your point of demand. And execution is now able to do the analysis quick enough, uh, which is why you don't need to do all that analysis beforehand during the planning. So in terms of the actual application of AI, we have seen AI application, like I mentioned, supply chain early warning. There's a good YouTube video that people can search for. It's called Infosys Supply Chain Early Warning. It looks at data internal to the organization as well as external. It looks at news blogs, Twitter, etc. It's almost as if the supply chain manager is able to read all newspapers in the world, and therefore is able to say, okay, there's a port strike in Chennai, and therefore the shipping from there is going to be delayed, or there is this industrial action happening in this manufacturer's factory that has been reported in this certain news, and therefore I know that that could be a potential issue a few weeks down the line in terms of my supplies coming in. So supply chain early warning is a big area. Predictive maintenance that we talked of in terms of manufacturing is also important for logistics, for fleet managers and so on, because predictive maintenance of the trucks themselves. Network optimization has become much more reliable, given the forecasting and the big data that you're able to apply into the network optimization. And so deciding on, should I take another warehouse on hire, Should I, treat one of my warehouses as a cross dock warehouse where I don't keep much stuff, but I just use it for as a transit point between trucks. All of those, can be done much easier. We have also done projects on predicting prices of logistics routes. So if you are someone who's buying logistics, who's basically contracting out to a carrier or a fleet owner, you can predict prices based on how prices have been trending. So even if you open it up for say an auction, what is a reasonable price to expect for a certain route. So again, these are just examples, but there are many more. The one other area I would like to touch upon is, even though forecasting everyone has been doing for a long time, but forecasting now has come to a stage where we are not even just forecasting demand, we are also forecasting returns. So when you talk about reverse logistics, that's an important part of logistics. When people return items, how do you finally get it back to the stock area, and then maybe back to the vendor and so on. So reverse logistics itself, also the spare parts logistics, how do a returned item, how do return items get repaired and so on. We are predicting returns. We are predicting returns, the possible cause of the returns, and therefore the spares that you should hold in inventory. So multiple places like that AI is helping this entire area. Dr. Anthony, would you like to add?
Yeah, I would like to add some of the problem statements which we have solved in the past, right? One of them is uh, uh, routing and predicting the delivery time of a parcels that we have done, which is already there in the production. And if we're talking about manufacturing, we can talk about scheduling, robotics, automation, uh, workforce allocations, and so on, right? Optimizing the workforce allocation and so on. These are the problem statements which we have solved in the past. Over to you, Sheshu.
I think this is the last question. We are almost over the time. Dr. Paranjay, what is the future of analytics with cloud-based ML, AI services, and what is the cloud strategy that you suggest? Let's keep it
Uh,
brief.
Hi, Seshu. When it comes to the cloud, there are a fantastic array of building blocks for data analytics and AI, which are available with cloud service providers, all the way from tools that allow you to pull data and create data lakes on the fly, to the rapid management of, hundreds of models literally at the same time, their quick deployment using containers. So the whole works. These are all available on cloud service providers, with cloud service providers. And the best part of cloud services itself is the aspect of scalability. So you can scale up to whatever size you want at a very short notice. You don't really need to buy separate machines and so on. The only downside is, what is it that cloud service providers will not really do for you? It is they will not customize for you. And that is the situation where I think, if any customer who's seeking uh, a kind of solutions that are customized to specific environments, there the best kind of approach is to define what would be the total solution and use many of these tools that are available out of cloud service platforms to generate the end-to-end solution. Over to you, Seshu.
Thank you very much, Dr. Puranjay. I think we are over the time, and number of questions, very interesting ones. I would like to thank all the participants who have raised very interesting questions, and also uh, our panelists for answering very interesting questions with real examples of work they have done based on their experience. I would like to thank. And if there are any questions that anything that you want to reach out, you can reach out to by writing to this mail ID infirec underscore feedback at infosys.com. INFI underscore feedback at infosys.com. Thank you very much, and have a good evening. Bye.
Bye-bye.
Bye. Thank you, everyone.